Okay, we're going to look at how to factor a quadratic expression if the leading coefficient is greater than 1, or I should say is not 1. And so we're going to look at this first one, 7m squared plus 16m plus 4. And we know that we can turn that into the area of the rectangle, and we need to think of which part goes into which part of our rectangle. And remember, the numbers that we write inside the rectangle are representing the area. The numbers outside represent lengths and widths. So we're trying to find the lengths and widths of each of these rectangles, each of these 4 that make up the full one. So we have our 7m squared as the area of the upper left. We have 4 as the area of the lower right. Where did that come from? It came straight from the trinomial. Now, these 2 in the diagonal, we know I need to add up to 16m. So that one there in the upper right corner and the one in the lower left corner are going to add up to 16m. So there are going to be some m's in the upper right, some m's in the lower left. So one thing that we need to keep in mind that we learned in class is that the diagonals have the same product. So 7m squared times 4 is 28m squared. So we need that upper right and bottom left to also equal 28m squared. In other words, the 2 coefficients have to multiply to 28. But they also have to add to 16 because that's how many m's we have in total in our expression. So they need to multiply to 28 and they need to add to 16 because that's how many m's we have. Now, we need to try to find these numbers. Essentially, we just have to search. There's no real easy way to do it, but the easiest way is probably to look at the 28 and think of factors of 28. So 7 and 4 are factors of 28, but 7 plus 4 does not equal 16. 28 and 1 are factors of 28, but 28 plus 1 does not equal 16. 14 and 2 are factors of 28. 14 plus 2 does equal 16. So we found our 2 numbers that multiply to 28 and add to 16, 2 and 14. 2 and 14 multiply to 28 and add to 16. So I know in one of them we have to have 2m, and in the other one we have to have 14m. So they add up to 16m and multiply to 28m squared. So now I need to look and I need to think, okay, I have the inside, I have the area of each of those small rectangles. Now I need to find the length and the width of each one. Well, I have up here in the upper right is 2m, and in the lower right I have 4. So what factor goes into both 2m and 4? Well, that would be 2. So why am I looking for factors? Because I'm looking for a length and a width. So that's length times width, those are factors. So if I put a 2 as the width of that part right there, we're going to have it possible to have an area of 2m in the upper right rectangle and 4 in the lower right rectangle. So that has to be 2 because 2 goes both into 2m and into 4. But if that's 2m, if that length is 2, let's call that a width. If that width is 2, then what does the length of the other side have to be in order for the area to be 2m? Well, that's easy. It just has to be m, because 2 times m is 2m. And over here, we need to have another 2. Why? Because 2 times 2 is equal to 4. So now I have the length of my big rectangle is m plus 2. I'm still missing 1. That has to be 7m. Why? Because m times 7m gets me 7m squared. So once I knew that m was the length of the top part, that meant 7m had to be the width of that left part to make 7m squared be the area. So I have 7m plus 2, and I have m plus 2 as my length and my width. So we can go ahead and write that expression in factored form. M plus 2 times 7m plus 2. Those are the same. Why are they both the same? Because they both represent the area of that large rectangle. If we multiply 7m plus 2 times m plus 2, we get 7m squared plus 2m plus 14m plus 4, which simplifies to 7m squared plus 16m plus 4. It's easy to multiply. It's a little bit more difficult when you're trying to factor, when you're trying to find that length times width. We have to be very thoughtful. Let's look at another example. How about 3n squared minus n minus 2? Well, we know that 3n squared goes here. We know negative 2 goes here. We know that the other two rectangles have to add up to negative n, and they multiply to the same thing as the rectangles we have. So they multiply to negative 6. So we're looking for two numbers that add up to negative 6, multiply to negative 6, and add to negative 1. So 3 and 2 multiply to 6, but we know one of them has to be negative. Well, it only makes sense if the 3 is negative, because negative 3 plus 2 is negative 1. If the 2 is negative, we wouldn't get negative 1 when we added them together. So we know that we have negative 3n and positive 2n. Let's just check. Negative 3n plus 2n is negative n. Good, that's what we have as our middle term in our trinomial, in our quadratic. And negative 3n times 2n is negative 6n squared. That's the same thing as the product of the other diagonal. Perfect. So now we have to find the outside. We found the area. We found the inside. We found the outside, which is the length and the width. So let's look for a common factor between negative 3n and negative 2. That would just be really just negative 1. They don't have any other common factors. So we have negative 1 has to go here. And then that means that over here we have to have 3n. Why? Because if the area of the upper right is negative 3n, we have negative 1 times what gets us negative 3n? Well, it has to be positive 3n. So our length is positive 3n on that part, which means that we have to have n up at the top and n times 2 to get us 2n. So we're done. We have n minus 1 and 3n plus 2. That's it. So 3n squared minus n minus 2 is the same as 3n plus 2 times n minus 1. Let's do another one. Alright, 5x squared plus 2x minus 3. We know where the 5x squared goes. We know where the negative 3 goes. The product of those two is negative 15x squared. So we're looking for two numbers that multiply to negative 15. But our middle term is 2x, so they have to add to 2. Great, so what two numbers? How about 5 and 3? But one of them has to be negative to make it negative 15. Well, the 3 has to be negative in order to get positive 2 when we add them. So we have 5x, we have negative 3x, and now we look for common factors. So here I see a negative 3 as a common factor, so I know that that length has to be negative 3. What else? I see, if that means this has to be x to get negative 3x. This one has to be 5x to get 5x squared, and that last one has to be 1. So we went a little fast here. Feel free to pause the video and go back and rewatch any of these parts, any of these examples. Make sure you have them all written down. Let's do one last one. This will be the last one. So here we have 3k squared, here we have negative 12. The product of the two coefficients is negative 36. So we're looking for two numbers that multiply to negative 36. And they have to add up to 5 because those two missing rectangles contain 5k. So they have to add up to 5k. So two numbers that multiply to negative 36 and add to 5. You have to search for them. Once you search for the products of 36, you'll find 4 and 9 work, as long as one of them is negative. In this case, it has to be negative 4. So we have negative 4k, 9k. We look for factors. I see negative 4 as a factor over here, which means this has to be k. Up there has to be 3k in order to get 3k squared, which means the bottom has to be 3. And we have our product of two binomials, product of two factors, as k plus 3 times 3k minus 4. That's it.